Okay, in this video I want to show you a little bit about some of the financial formulas that we have. If you open up the starting workbook, you'll see a single tab with a pre-formatted table that is loan payment based on the number of years, the loan amount, and some sort of interest rate. So what I'd like to do is calculate these monthly loan payments based on these characteristics of year, loan amount, and rate using the financial formula or function called payment. Let's go ahead and take a look at the financial formula. I'm going to hit Financial under the Formula ribbon. And as you can see, there's a wide variety of formulas here that we can use. Let's go ahead, and the one I'm interested in is payment, so let's go ahead and open that. We see the function arguments. We have the interest rate. We have the number of periods in per. We have the present value. And then we have other things such as future value and type. Well, I think we're all accustomed to at least the first three parameters of this function, but perhaps maybe not the last two, and definitely not the last one called type. As you can see here, type is a description, is a logical value. Payment at the beginning of the period equals 1, payment at the end of the period equals 0, or omitted. So if you would want more help on this particular function, we can always access the help feature, which is fairly good. It gives you a short description, calculates a payment for a loan based on the constant payments and a constant interest rate. Payment has the syntax rate, MPR, PV, and you'll see these two parameters in square brackets, which generally mean these are optional. So we can actually leave these out of the syntax. If, for example, we don't have a future value and we want to omit this value, which it will default as 0. Okay, so down here, if you wanted to see more information on type, 0 or omitted, so if we leave it out, it's going to be based on the end of a period. And if we put 1 in, it's at the beginning of the period. Again, Excel help file is pretty good. It shows you some remarks, in terms of interest rate. If you have monthly payments for, let's say, a 4-year loan, and the annual interest rate is 12%, we must divide that by the number of months in a year to get a rate that is suitable for our problem. Okay, it also gives us an example here. If you'd like to follow that on your own, you can actually export this data into Excel and work on it. So let's go ahead and get started with our problem. So in terms of the rate, we don't have any of this entered. So before we start entering some of these parameters, I'd like to take a minute and fill out the remaining portion of the table. Again, the whole strategy of Excel, a good practice is to build your spreadsheet in a way that's dynamic, that I can change the number of years. Maybe I want a 15-year loan. I should be able to type this value here. If I want loan amounts, maybe I'm exploring what I would like to actually ask for, and maybe this personal loan starts out at $10,000 and perhaps increments by 10,000. So I can actually reference this cell here to the left and add another 10,000. And if I want to bring this cell reference across the formula, we can quickly generate this table. Perhaps I want to start my loan rate at 3%. Notice we already have this formatted as a percentage. Otherwise, if it wasn't, you should enter that in as 0.03. In a similar fashion, I'm going to add a 0.5% to this 3%. So I'm going to reference the cell above and add 0.005, which would be a 0.5%, and go ahead and fill this down. Okay, so let's continue with this example. I've got my rate filled in. which I'm going to go ahead and apply this border just to make this complete. We've got our loan amount filled in and our rate filled in, and certainly our number of years. This necessarily isn't descriptive enough for me in terms of the headers. Loan amount is, of course, this is the loan amount over the entire portion of the loan. But rate, I'm not exactly sure if this is annual APR rate or a monthly. So what I would do is recommend putting some sort of description in the header itself. So I'm going to say yearly. So it's very clear what this rate represents, because we might actually have to do some modification within our formula to get this in terms of the right monthly payment. So maybe even the loan payment table is not descriptive of a month. We can go ahead and say that this is a monthly payment due. Okay, you might even want to add another row in terms of the number of periods. So let's go ahead and hit insert. And go ahead and use some formatting techniques of merge and center. I'm going to go ahead and border that and just calculate the total number of months. So that would be 15 times 12, or 180. In terms of the payment function, let's go ahead and start that. PMT, it's going to ask for a rate, but again, this is a yearly rate, and our table is in terms of months. So what you might want to do is either expand the number of columns you have for rate, where you are given yearly and you calculate monthly, or simply change the function here in the parameter. So what I'm referring to is actually dividing 3 by 12. So that's probably the easiest thing to do. So in this case, let's go ahead and reference the 3%, but divide this by 12, the number of months in a year. The NPR would be referring to our 180 months, and our present value, if we ask for $10,000, would be in fact $10,000. And at this point, we can go ahead and close the parentheses and hit enter. You'll notice if this is formatted as an accounting value, it actually likes to put these parentheses around any negative value. Payments are a negative cash flow item, so that's why you're seeing that. If you didn't want the parentheses to show, what you could actually do is multiply this formula by a -1. So -1 times payment will go ahead and display that positive value for you. So either way is fine, whichever way you want to do it. So now we got to think about how to fill out this table given this function we already implemented. So let's go ahead and drag this to the right, and we should expect errors. Why? Well, we didn't use any dollar signs. So what I tend to do is fill my formula to the right and double click the very last cell. I can instantly see this blue reference to the number is wrong. I expected this reference to be all the way back here at 3%. And I expected this reference to 180 to actually be on 180 and not here. So we have some fixing to do. Let's fix the rate reference, and then the total months. So what you're going to want to do is actually go back to the very first cell that you implemented the function and decide where you need your dollar signs. In this case, if I'm going to fill to the right, I need to lock that column. If I'm going to fill to the right in terms of the pink reference, that's okay. I don't need to lock in a column fashion. But if we're going to fill this formula down, I certainly need that dollar sign there to lock the row. Because as I drag this formula down, I don't want the reference to $10,000 to change. Okay, well, what about the reference to 180? This actually needs to be locked in both the column and the row position, because I never want this to change. So let's go ahead and hit enter. We still have our $69.06. If we fill this to the right, we have the correct payments amount. We can fill this formula down, and now we have an entire table here of correct values. So double click on the very last cell. We see 180 is still referenced, 5% is still referenced, and $40,000 is referenced. So we're good to go. Now you might want to do some formatting to get it back to the way it was at the start. If you want to remove those borders, you can go ahead and do so by removing the borders there. Let's go ahead and add our thick border back. And it looks like the only thing that needs thick borders is this range, total months. We didn't do that before. So it looks like we're all set. So again, let me briefly review what we've done. We've really critically thought about the labels. And one of the labels that wasn't descriptive enough for me was actually the biggest label here. Loan payment. Was that the total payment of the loan after 15 years, the total interest, or what is it? It's actually the monthly payment is what we desired to have in the table below. If that's the case, we should make the rest of the table very clear. Rate in terms of a yearly interest rate. We needed a total months or the total period for our payment formula, so we went ahead and calculated that and entered it in the table. Certainly we could have integrated that into the formula here for MPR. We could have just referenced the 15 times 12. So either way, I wanted to do an example of both where you modify the portion of the formula here, in this case dividing the 3% by 12, and then I wanted to show you an alternative strategy, which is to simply add another row and calculate that. So the idea is a user could come here and say, well, I want a 10-year loan, and that's going to directly calculate the total months. Maybe the interest rate is more like 5%. So this would give you an automatic step size of 0.5. We can even create cells for that if you really wanted to, which is fine. We can control the step size, control the starting interest rate. We could even control the loan amount, the starting value, or the increment size. So here is 10, maybe we wanted 25,000. So what we have here is basically a dynamic table with a few inputs that'll dynamically generate this output.